Section 3.3, Systems of Inequalities. So the difference from 3.3 and 3.2 is now that they are inequalities instead of equations. So I just want to remind you of a couple of things. Remember, if it's greater than or if it's less than, you are going to use dashed lines. If it's greater than or equal to or less than or equal to, you're going to use solid lines. Remember, greater than or equal to, you are going to shade above the line that you have graphed. Less than or equal to, you are going to shade below the line that you have graphed. So in section 3.3, we are only going to be solving by graphing. The book talks about using a table to solve these systems, but we are only going to do it by graphing. So right now you only know how to graph two equations. You know how to graph lines, you know how to graph absolute value functions. So you need to ask yourself in example 1, are these lines, are they absolute values, are they one of both? So if you notice, they are linear. There's no absolute value bars, so you need to put both of them into slope-intercept form so that we can graph our line. So I am going to subtract x to the other side, and then I'm going to divide by 2, so that gives me y is less than or equal to negative 1/2 x plus 2. So remember, if you were to divide or multiply by a negative number, it is going to switch your inequality and make it point the other way. So if you notice, both of these are less than and greater than or equal to, so I'm going to have two solid lines. So let's start by graphing our first equation. So at positive 2, I put a dot. And then I go down 1 and I go to the right 2 and I put my second dot. Again, since it's less than or equal to, this is going to be a solid line in between these 2 points. And since it's less than, I would shade below my line. Okay, let's graph our other line. So I have a y-intercept of negative 1. I go down 1 and to the right 1. Again, since it's greater than or equal to, it's going to be a solid line. Okay, and since it's greater than, we are going to shade above that line. Now, since it's a system of equations, you are looking for where the section where both lines are going to be true. And they are both true inside this middle region in here. So this shaded region in between the two lines would be your answer. Alright, press pause right now, and I want you guys to try example 2. And I want you to find the system to this, the answer to this system. So for you to begin your graph, you have to get them in slope-intercept form. So in my first equation, I just subtracted x to the other side. So now my second equation, I first need to subtract my 3x. And then I need to divide everything by 7. So that's going to give me y is less than or equal to negative 3/7 x plus 3. Okay, let's start by graphing our first line. So at positive 4 on my y-axis is my first dot. And then I go down 1 and to the right 1. And since this is just greater than, this should be a dashed line. And since it's greater than, you should shade everywhere above it. Okay, let's graph our second line at positive 3 on your y-axis. And then you go down 3 and to the right 1, 2, 3, 4, 5, 6, 7. And since this is less than or equal to, that should be a solid line. And since it's less than, you should shade everywhere below this line. So again, since it's a system, you are looking for the region where both are going to be true, and it looks like they are both true right inside this region over here. So this whole green region is the answer to this system. Any point that lies inside that region would be a true answer. Now we are going to move on to solving a system that both has a line and an absolute value function in our system. So let's look at our first example in this section. So we have y is less than -1/3 x plus 1. So this is my line, and it's already in slope-intercept form, so that's good. And then I have y is greater than 2 times the absolute value of x minus 1. Okay, so let's start with our line. So I'm going to put a dot at +1 on my y-axis, and then I'm going to go down 1 and to the right 1, 2, 3. Okay, since it's just less than, this should be a dashed line. And then you are looking to shade everything below your line since it's less than. Okay, so now the other function is our absolute value graph. So I need to determine my vertex first. So my vertex, if you remember, is h comma k. H is the number inside your absolute value bars. So you see -1, but remember it's always the opposite because that means it moves to the right one. And then k is the number at the end, so there's no number at the end. So I need to graph the point 1, 0. Okay, and then 2 is the slope of my v, so I need to go up 2 and to the right 1, up 2, and to the left 1, and if you notice that will also be dashed because it is just strictly greater than. And then you would need to shade above your line, which would be inside your actual V. And you are looking for the region where they overlap, and unfortunately this is a really tiny region. It is right inside in between my V and my line. That is the answer to your system. This is your last example, so press pause and I want you to solve this system. So the first equation in this system is your absolute value graph. So you need to find the vertex. So the vertex, remember, is h comma k. So since it's +1 on the inside, it's -1. And since it's -3 at the end, it stays the same. So I'm going to first graph the point -1, -3. Okay, now the slope of my V is -1/2, so I need to go down 1 and to the right 2, down 1 and to the left 2. Okay, since it's less than or equal to, this needs to be a solid V. And then you need to shade everywhere below your V. So the other one, y is greater than -6. So that is going to be a horizontal line at -6. And it is going to be a dashed line because it's just greater than. And you would need to shade above your line since it was greater than. And then you're looking for the region where the two sections overlap. And it's right in between your V and your line. So there could be times when there is no overlap at all, and then your answer would be no solution to your system.